Hey everyone, thanks for tuning in to this week's MonSec beginner workshop. So today, hi, my name is Richard. I'll be going through some further web application pen testing and security material. So the way I've got this split up today is two parts. First, we're going to go through a bit of general web as well, so client-side versus server-side validation, directory and intelligence finding, and some various miscellaneous things about that. And then in the second part of this, I'm going to be going through cross-site scripting, which is a technique by which you can steal a user's session and further privilege escalate from there. So without further ado, let's get started. So what I've got here today is PicoCTF, which is just a nice test bed that has some fun challenges that are good to demonstrate the principles that we're talking about today. So if you remember a couple weeks ago, Mariusz took you through some basic NATAS, that's another CTF. So PicoCTF is much like NATAS, except it has a few other challenges, and it has, well, quite a few other challenges, and they're in a whole bunch of different categories. So for example, PicoCTF also has an inspect element browser challenge because, well, who doesn't these days in terms of beginner CTFs? So the first thing I want to talk about today is client-side validation. So when we talk about a web server application architecture, what we're looking at is, so you have a client, which is your browser, and you have a server, which is, well, a web server. And there are two places in which you can do validation for. So for example, if I type in ASDF here, I get an alert saying incorrect password. But we'll note that if we go into the network tab here, when I say verify, nothing actually gets sent to the server. So this is a case where we can see that there is client-side validation going on, and nothing's being sent to the server because either it's not handled at the server level or it's being caught before. So that's interesting. We don't actually know what the password is, but at the very least we want to get past the browser not letting us do things, because the browser is a machine we control. It's supposed to work for us. So with that in mind then, we've got our inspect element open, handy, trusty inspect element, and we can see here that we've got scripts. So JavaScript, which is the client-side language that the web server passes you some script for, and it says, oh, okay, we're going to verify this. So this is an interesting function. It's defining a function called verify, and you can see here pretty clearly that in the context of this challenge, it's actually a flag and the alert password verified. So the mistake that, or the intentional mistake or challenge in this case, is that instead of doing password validation on the server side, they've in fact hard-coded the password into the client. This is particularly bad as a form of verification because not only could you make a request to the server without the password and imitate a logged-in user, or rather not require any authentication at all if you knew how, but you can actually find the password right here. So if we type in Pico, whoops, let's do this here. Pico, actually. So in this case, this is actually looking at, this is slightly more difficult than this order because we can actually see that this is doing substring splitting. So a second part of this challenge is actually just figuring out and reading what this code does, which is just splitting the password into blocks of 4. You can see split 4 here, and then verifying each section. So if we look and just follow the numbers, we'll come up with the password. So PicoCTF, so that's to 2. Now we're going 3 to 4. 2 to 3. No underscore C. So now we're going 3 to 4. Client 4 to 5. TS underscore P 5 to 6. Plus underscore E 6 to 7. B9 5 6, and then 7 to 8. And if we type that in, we should get password verified. So this was not only some reverse engineering, as in we're just reading what the code does, but also a demonstration of some particularly bad client-side verification. I'm going to take 30 seconds both to open up the Twitch stream and to check if there have been any comments or questions on this particular challenge, and then I'll move on to a couple of other interesting ones. Alright, looks like we've got nothing so far. Please do ask any questions you have, or just put any comments you have in the description. In the chat. I have someone monitoring, and I've got the stream up as well. And that way we can have some nice interactivity, and we can talk about things I've missed, or just various areas that you guys find interesting. So, back to PicoCTF. So, what I've got here is just a web app section, which honestly is just like a really, really great generalist beginner web application CTF. You can even look at hints. So the next thing I'm gonna look at is a bit of actually, let's see, client side again. Nah. Next thing I'm going to look at is a bit of reconnaissance. So one of the things that you want to do, and this is less applicable in a CTF context, but far, far, far more applicable in the context of real-world penetration testing. So I interned at EY's Advanced Cybersecurity Center over this summer holidays, and one of the things that you realize is that CTFs are really great, but the real world tends to be a lot more boring, and there tends to be a lot more boring vulnerabilities and mistakes. And one of the most common mistakes that people make is just leaving a resource exposed and not password protecting it, and thinking, oh, well, no one has the URL, so that's fine. So, fortunately or unfortunately for the world, computers are really good at trying lots and lots of things, and this is a technique called brute forcing. So, you can try lots and lots of URLs very, very quickly and find common ones from a common list that and that can often expose very important files. So I'm going to show you a tool today called Dirbuster, but there are many tools like this, and it really doesn't matter what you use. And the basic principle that we're going to explore here is trying a whole bunch of different common URLs from a word list and seeing what we get. It's worth noting also that there are tools like Burp Suite, which have tools like its Spider, which will go through and click on every single URL and that it finds and every piece of content, and then catalog that for you as well. So, Dirbuster. So, I've got Dirbuster up here, and for those of you that have Kali Linux installed, you won't have to install this, but it's a pretty simple utility to install. You can go find that yourself if you want. So, we're going to put in our target URL, and then we're going to put in our word list. So, Dirbuster comes with its own word list, or set of word lists rather, and because I actually already know what this challenge is, I'm going to use a small one so that we can go through it quickly. This is all fine, and let's go. So, actually, just a moment before we go through and run this, I want to show you what one of these word lists looks like. So, if we have a look at, say, directory list 2.3 small.txt, we can see that this is literally just a giant list of directories that are common, default, index, events, help, security, category, whatever. So let's run Dirbuster, see what happens. So we're going to start, and we're going to start scanning for directories. This is also doing a scan for .php extensions, just because many web services are made with PHP, and that can be useful. Now, this is going to take a long time, and I already know what the URL we're trying to find is, so I'm going to skip ahead, and I'll move this to the side, and we'll check back later and see if it's gotten the URL that we're looking for. So, in this case, what we're looking for is a common file called robots.txt. Robots.txt is a file that you use if you want to tell Google what to find and what to index and what not to index. So Google as a service will crawl through the entire internet, and when it gets to your website, it'll check for robots.txt, which will tell it, hey, this is what you should look at, this is what you shouldn't look at, and it's basically a pretty please. There's no actual access control going on here. What this means is, for example, some people don't realize this, and you can see here that they said disallow /ae3f.html. What this tells Google is, hey, please don't look at this. Well, I'm not Google, and I really don't care about what your site is trying to tell me, because I want to break in. So we're going to have a look here. And oh, it's a flag, wow. Turns out that the secret thing that they didn't want us to find, we can still access, because they told us they didn't want us to find their secret thing, and they told us exactly where it was. So, that's sort of most of what I wanted to touch on today in terms of just reconnaissance. This is more of a bit of a standalone thing as a, hey, if you're ever doing a CTF or a challenge, or, God forbid, trying to hack into something more real world, then this is a pretty integral and common step of reconnaissance, and it's just a general sort of thing that is really good to know. Just to round off this section, I want to do 2 more challenges, Open to Admins and Pico Browser. These are more examples of client-side vulnerabilities, or rather, examples of your server trusting the client way too much. So, this site here, if we have a look, says, this secure site allows users to access the flag only if they are admin, and the time is exactly 1400. Okay, that's interesting. So let's go and have another look at what's going on here, and go through our normal steps of just browsing through and looking at, you know, what's the site doing. So I'm gonna go here, I'm gonna go have a look at the index page, read through some of the HTML. Okay, loading up some JavaScript, you got some presentational HTML. That's all fine. Alright, what else is going on? So, the network tab is often a far better resource than the sources tab, because the network tab actually shows you what's getting sent from the server to you and you to the server. So if we have a look at this request again, we can see a whole bunch of headers. Now, headers are basically bits of metadata that you and the server send back and forth to tell them what's going on. This is because HTTP is a stateless protocol, which is to say that all of the information about a request should be contained within that request, which means you have to tell the server what's going on every single time. In this case, we can see that we have, let's see, host, cookie, some connection, some other request headers. Cool. Alright. And that's our site response. Let's see what happens if we hit flag. Now flag says, I'm sorry, it doesn't look like you are the admin, or it's the incorrect time. So that was us navigating to this flag here, and we got a GET request that said 302 found, blah blah blah, we got a preview response. Okay, so far, not much. Let's try having another look. Okay, and let's see. Oh, where am I? Alright, so we have a session cookie here. Now, this looks interesting. What a session cookie is essentially it's a cookie that defines or identifies what your session is or what current browsing session you're using to the website. So this is a way that you can identify basically that this request is coming from a specific user or a specific session, which is why we call it a session cookie. And yeah, so that lets you do things like track state on your server. So let's have a look at this session cookie. By the way, if you get stuck, you can have a look at hints on PicoCTF. So yeah, so for example, here we see, can cookies help you to get the flag? So if you didn't know what a session cookie was, or if you didn't know what cookies were, then that could be something that you could go through and have a look at and go, okay, can cookies help you get the flag? You go research what cookies are, and then you go, there's a cookie here. So these cookies here are Google Analytics, so _GA and _GID. They're used for Google Analytics, which is a service from Google that helps you, that basically allows you to track statistics about your website. So that's completely fine and doesn't actually... Cool. Now, in this case, the session ID isn't super important because, whoops, where'd we go? Network. Sorry, I've just got to be right back for one moment. Oh, okay. Are we off intermission? Cool. So about that, everyone. Just had something personal. We're back now. Anyway, as I was saying, and I'm not sure if this was on the stream or not, so bear with me. This challenge is actually a little weird because it doesn't actually set a cookie for you, which is normally how you'd start looking at the data. It actually it's a little badly designed, and it actually wants you to set your own cookies to tell it what's going on. So what we're going to do here is we're going to set two flags. We're going to set a cookie called admin, and we're going to set that to true, and we're going to set a cookie called time with the value 1400. So what I've done here is I've done this using the browser console. I'm going to show you a different way to do this in just a moment. Let's see, what have we screwed up here? Admin and time value equals true. Let's have another look. Cookies. So, by the way, this is another way you can access the cookies on the server. Let's see. So that should be working, but it isn't for some reason, as live demos almost always don't. Mariusz has given me a comment saying maybe it should be lowercase, so we'll try that, and if that doesn't work, I'll just move on to the next one. Let's try that again. Oh, okay, so it was lowercase. My bad. Like I said, this is a bit of a weird challenge because it doesn't actually set the cookie for you, which is normally how you'd expect to see what a server's doing. So the second thing I wanted to do with this challenge was use it to showcase a tool called Burp Suite. Now, I'm not a huge fan of Burp Suite for a lot of things because I think it's slightly bloated and slightly too much for a lot of use cases, but it is a really powerful tool, and it's a really useful tool to know, especially if you're planning on going into a cybersecurity career, because some of the logging things are, well, essentially non-negotiable, because you need to tell a client what you've actually done. So this is Burp Suite. You can get it for free. It's a free tool, although it does have an enterprise edition. And Burp Suite have a lot of different features, but the one that we care about today is the proxy, or the interceptor. So one of Burp Suite's main features is that it can intercept the requests that your browser is making. So much like how your F12 menu has a network tab, Burp Suite actually puts itself between you and your browser, between your browser and the server, and lets you make modifications to requests in flight. So I'm not going to go through the installation steps here. You can find those in your own time if you want. Burp Suite itself has a great tutorial for that. So I'm just going to turn my interception on. Yep, we've got some random stuff going on. Okay, and I'm going to refresh. So here we go. Request to 2019 shell 1 picoctf 443. You can see it's get request, headers, etc, etc, etc. So I'm going to let that go through, and I'm going to try and grab the flag. So I've just got a whole bunch of stuff going through burp because I let Twitch go through here. See if burp captures this again. Okay, here we go. Headers, hex, blah blah blah. Ah, that wasn't a request to get the flag. Yep. Okay, let's get the flag and let's see if this intercepts it now. Check, check. I've been informed that we're streaming again, so let's see if this works. Cool. Welcome back, everyone. Sorry about the various trials and tribulations over the past 5 or so minutes. I had a machine crash, and then we had some problems with our streaming setup, but we're back, we're live. I feel like I've said this phrase 4 or 5 times now, but hopefully this will be the last time. So where we last left off was demoing Burp Suite. And so what I've done here is I've prepared, so we've got an intercepted request to flag, and we can see that we've got this request trapped here in flight with burp. So it's interesting because unlike in the network tab, because this is trapped here, I can still edit things here. So what I can do is I can do cookie admin equals true, and actually I'm just going to double check the format of this. Whoops. Alright, so we can do admin equals true and time equals, I believe it was 1400, and forward that and get a response. So that is not what we're looking for. And we've got the flag like that as well. So Burp Suite is another tool by which you can interact with websites and web servers. Now, that's not so useful here where, you know, you can do it in the browser and it's kind of easier than installing and learning a whole new tool, but Burp Suite can be very useful for if you're doing a lot of this in order to streamline your workflow and catch things that you might not otherwise have with tools that are intended for developers, not pen testers. Burp Suite is built for web application security. Please don't tell me Pico CTF is actually down. That would be tragic. I'm going to log into my LastPass as well, which has decided that computer crashing means that someone might be doing something bad. So yeah, apologies for a lot of this going a little more awry. My machine crashing has closed off a bunch of things. It looks like my Chrome session is still there, so I'm just going to move on. So, where were we? Web. Actually, I will need Burp Suite because the whole point of this last one was Burp Suite. That's fine. We're going to move on. So, the second part of this, or this talk, I suppose, is talking about XSS or cross-site scripting. So, what XSS is it's a vulnerability by which you can inject your own HTML or other code, or other codes such as JavaScript, basically, into a client's browser, and then use that to do nefarious things. So, let's go to Google XSS. So, Google have kindly put together a set of fun challenges for learning about XSS, which we're going to look at today. That wasn't what I was looking for. Well, this is fine anyway. So this is an example of like a comment on a website, and if we try entering, say, a bold tag like this, we can actually see that it bolds. Now you might go, oh, that's harmless. I mean, you know, letting your users do a bit of formatting, you know, let them play around. You know, that's pretty cool. The trouble is that you can do a whole lot more than just some formatting. If you're in the right context, you can impersonate the web page and pretend that it's an announcement, or what we tend to go for and what is the holy grail for XSS is executing our own arbitrary JavaScript on the client. So I'm going to do an alert tag. Wrong demo. Let's see. There we go. I don't know what my typo was, but that works. So you can get an alert, and this is the typical way you test or demonstrate XSS is if you can get an alert or something to show up using JavaScript, then you're good. Now, that's fine and makes sense in a theoretical context, but why is this dangerous? And it's worth noting that XSS is one of the most common severe vulnerabilities in web applications, even to this day. The reason it's dangerous is because if you think back to some of the stuff we looked at earlier, for example, the browser session in particular, we noted that that browser session is what the site uses to identify who you are. And that session is basically a unique identifier, but when you log in to a website, for example, it uses that session to say, okay, this user has logged in as Richard. We don't need to ask him for his login again, because we know that this is Richard. The thing is, you can impersonate that session if you can extract it. So let's go to storage, cookies. Hopefully there'll be a cookie on this website. No, whatever. So that cookie, as we showed earlier, we can send to anyone and modify the request. So we can construct our own request with our own cookie. What that means is then that if we can grab that cookie, we can impersonate a user. I'm being informed that there's a question or a comment or a suggestion, so I'll take a moment to answer or respond or just hear that. Cool, so the question, or the comment rather, was just about the demo, noting that because the blog doesn't actually reload, it won't trigger that code, because the way script tags work in the browser is that they get sent down when the page is loaded, and they get passed and executed then. That was just me using the wrong the wrong demo. I meant to be using this one. He also comments that localhost is my most visited website, which, yes it is. I do a lot of web development, so lots of local web servers. So the last thing I wanted to show you was how you can actually exfiltrate data, because it's all well and good to be able to execute stuff here and do, you know, script alert, but that's kind of boring and if you're looking to try and get a user's cookie, well, you need to actually get it to somewhere where you control. Now, the traditional way of doing this would be setting up some kind of server which you can send data to and then log that, but that's pretty cumbersome, and if we're doing CTFs, well, we're allowed to do what we want, and we can use services built for something like this. So I'm going to show you a service called XSS Hunter. XSS Hunter is really, really cool, and it's run by some dude. But what it essentially does is it takes away a lot of that pain of setting up a server and trying to get data exfiltrated. So not only does it give us a whole bunch of payloads, which is pretty cool, it also actually allows us to fire XSS requests to a URL, so delordish.xss.ht, which is my account, and then it'll even exfiltrate a whole bunch of data and show you what the page was. So, I had a more elegant demo set up with a proper fake document cookie, but it's going to take too long to set that back up. So instead, I have a really, really basic... Whoops, that was a private key that I'm not using anymore, thank goodness. I've got a really, really basic one. So, you're going to have to take this leap of faith with me, in that I don't have a demo set up that I'm going to show you the full process, but that demo there should have shown you that, yes, there are cases where we can execute arbitrary JavaScript on a client. And if we can get it to execute something like this, like of our own, which I'm going to do by simply visiting this page, then we can actually go and exfiltrate data. So if we have a refresh, then we'll see that a third one's come up and we can see what's happened. Now, yes, that is my IP before anyone comments on it. No, I'm not particularly worried because I have a dynamic IP address and there's nothing available on my home network. So before we leave off, I want to leave you with some good resources for XSS. So the first one, which is the actual demo I wanted to show you, is the XSS game. The XSS game is something produced by Google, and it's simply a way to learn about XSS from an attacker's perspective. So in this case, it's really nice because it actually shows you the target code, which means we can actually read the code and see what protections they've implemented here. In this case, I believe there are absolutely no protections, so we should be able to type script alert and advance to the next level. This gets progressively more difficult, and there are more and more protections or just difficult situations. So this one here, for example, is actually from the previous site, which I think I've closed. But this one, for example, where am I? Doesn't reload the page, so you need something like an image XSS. So, for example, if we look at payloads, we can actually see that, for example, there's an image payload here. The second resource I want to show you is the OWASP XSS payload cheat sheet. So, the way a lot of services defend against XSS is by filtering out fancy characters, etc., and that's often what you'll find in a CTF competition. Basically, this is just a giant list of payloads that you can try to use to bypass XSS protection. So it ranges from anything from a polygon locator, which should work in a ton of different locations, which is often a good one to start with. Hey, we just advanced to the next level without even understanding what this does, really. it's got a whole bunch of things that work and don't work. It's often really good to just start chucking these payloads in and going at it. I did have some more XSS content prepared, but like I said, all my demos were a bit ephemeral, so I'm going to end off here and hand off to Daniel for the advanced workshop. I'll just wait for a minute or two to see if there are any questions or comments, and then we'll hand over. Alright, looks like there's nothing, so I'm just going to end off with a few plugs. So first off, please do fill out the attendance form. It really helps us out, both with tracking of numbers, sponsorship, things like that. So hopefully it'll help you get pizza when we get back physically. Also go to the MonSec link to join, and if you have any feedback, please do go to the survey link and tell us. We read every single comment, and we're always trying our best to improve. Alright, thanks everyone. I've been Richard.
And more specifically, we will be going over some Android app exploitation. So, as you can see in the reverse engineering section, we've got... Oh, I forgot to mute myself. Wonderful. Okay. Where was I? Yes. So we'll be going over some of these. These are a little into the reverse engineering. You will have to complete some of the previous ones before getting the Android apps, but that should be no problem. So, let's start with Droid 0. Where do droid logs go? So let's get this file and let's just download it. And as we can see, if we go into, let's just make a new folder. And drag it in. So, yeah. All right. So yes, so somebody asked how to get access to these problems. They won't show up immediately, just basically go into some of the other reverse engineering ones. You'll probably be seeing things like Vault Door Training, Vault Door 1. You basically just need to solve these few here, and then you can get to Droid 0. It's a little further down the list. So just do some of these, and then you can get into it. But anyway, so we've got this APK. Well, if you know anything about mobile development, you know that an APK is the package basically for an Android app. Slight problem, I'm on a desktop, not a phone. So we have something called Android Studio. And with Android Studio, you get this lovely little emulator. So this is what it thinks is a Pixel 3, but it's actually just the equivalent of a virtual machine. So if we go and drag and drop this APK into here, that's all you need to do to install on this. It should have installed. Swipe up, and we can see that we now have a new app called PicoCTF. We go into it, and we have a button. But it doesn't seem to work. Maybe we need a password. Still nothing. Well, one of the first things you would notice is that in Android Studio, ignore this is just an example thing that I needed to start the emulator, we have this console. And it seems to be outputting quite a few things. We don't need any of this, so we can go up here and we can switch from this application, which was the test one I had up earlier, to PicoCTF. And as you can see now, every time I hit the button, a new flag will appear. So this is something called logcat. You can see down here, logcat. This is basically just the equivalent of the JavaScript terminal. Sounds pretty simple. So let's move on to the next one. Same thing again, download the file. Let's put it into our folder again. Get rid of that. Also, sorry about my stream. It is going to glitch out quite a bit. That's the problem of being on Arch, or Manjaro, rather. So yes, what was I doing? So yeah, now we've got the one APK. We can go in, exit out of that, install the next APK, and you can see that nothing really changed here. That's because the system actually sees these as two different versions of the same app, so we just go back into PicoCTF. And this looks very familiar. So we can hit the button, we can try and put in a password, nothing seems to happen. And if we go into the logs now, the active logs, nothing actually seems to be here. So this is where we start having to delve a little deeper into the code itself. and this is where we need something called APK tools. So if you're on Kali, I think you can just apt-get this. If you're on Arch, it's in the AUR. If you're on some weird Hannah Montana distribution, install it from source. Really. Cool. So if we open a terminal and we go into the folder, then we can go, well, why don't we start off with just this, the very first command. It shows us what to do. So APK tool, D, and then what was the name of this one again? 1. This will go about a little bit. There we go. And if we look back in the I've been informed to make the terminal font bigger, so there you go. I don't know if that's big enough, but hopefully you guys can see. All I did was run the APK tools the exact same as what's on the website. So this output a folder. This folder, as you can see, has the exact same name as the APK. And if we go into here, this is just a bunch of files. It seems to have decompressed the APK in some way. If we actually have a look at this example, one that I had earlier, we can see that in a very similar way, where is it, in res, if we go into the res here and the res in here, we have, well, it's hard to see because there's a bunch more things in this one, but basically this is just the code of the APK. It's what all these folders eventually get compiled into. So if we have a look in this code, maybe we'll find something for flag. Well, we don't quite find something for flag, but we do find this file called flagstuff. And if we go into VS Code, because it makes it a hell of a lot more pretty. Oh, and I opened the wrong thing. What's happening? Alright, problems of that. Alright, cool. What's happening in here? Don't save. And there we go. Cool. So as you can see, I've just loaded it in. See if I can. Let's do that. Go away. So yes, let's go see where this file actually is. Just go to properties. We can see that it's in one smiley com hello simu whatever. So hello smiley com, and there we go. So this is just an interesting file that I found, and we can see here that it is, go away. We can see here that it is not really Java. I mean, there's references to Java, but what is this syntax? Just what's going on here? Well, if we actually have a look into what's going on here with the actual name of it, so Smiley, we can see that, where is it? What is Smiley in Android? Looks like a good thing. We can see that it is basically the disassembly format used by this. More or less, it is the opcodes for Android. Like in x86 and AMD 64, you'll have things like move, add, sub, stuff like that, and in MIPS you'll have something very similar. This is just that, but in Android terms. So, if we actually have a look here, where did my... there we go. So yes, if we actually have a look at this file, we can see that there are a few different things going on. We've got a constructor, and we've got something called getFlag. So getFlag is probably what we want to look at, just because, well, we want the flag, don't we? So this is kind of confusing. What's going on here? What's going on here? basically, what's going on is this is just setting the variable p0 to whatever input was from this function. We get p1 as the context, which is very important if you've ever done mobile app development. And then we get this basically just puts this variable into this one, so on and so forth. And then we get into invoke virtual. Okay. This is getting into a little bit more architecture specific stuff now. So back to Google. Oh hey, that's the name that we saw earlier. Let's go into here. This is actually a really useful resource because, as you can see, it gives you the hex code or the opcode, the actual what it would look like to human readable, which is what this is, and then it gives you little explanations and examples of what's going on. So if we just search for invoke virtual, we see that it takes the parameter, it invokes a virtual method. It looks like the virtual method here is to get a string. Okay. And if we read this, basically what we can find it's doing is that it's actually invoking get string from the context and find the string with the ID of what's in v0. So we're getting the string with the ID of this. So, alright, let's find where the idea of this is. You can find this statically in the APK just because of how it's built. It is in one of the manifest files. I can't remember for the life of me where the manifest actually is. It's in one of these. Or what we can use is grep, or a really cool version of grep that I only got showed the other day, which is called ripgrep. So that's RIPGREP. Shortens itself down to RG. So if we go into this directory and we just search for this, we get in the file one.res values public XML, which is the manifest, we see that this string has the ID of this, which is what we want to look for, and it has the name password. Alright, that's interesting. But that's only the manifest to say that it exists. Where is the static file that actually tells us this is what it's set to? Well, if we just search for the name again, we can see in here, in the res values one, you actually get strings.xml, which is what actually tells the APK this is what this string is hard-coded to, and we can see that it's opossum. So we take opossum, we put it in place of the password up here. I forget that you can't control V in this, so let's just type it in, and we run it, and we get the flag. And again, you can't copy and paste, so have fun writing that out. Alright, so that's pretty simple. Let's move on to... one moment. Let's move on to the next one. Actually, I'm going to take this opportunity right now to see if there are any questions, either on Twitch or on Discord. Doesn't look like it. Cool. So let's move on to Droid 2. This one, rinse repeat from the last few times, save the file, get an APK. You know the drill by now. Oh, screw up because you forgot to actually exit out from last time. Go back to temp. Move this into here. And alright, let's load in 2. Drag and drop again. Man, I like this emulator. Go back into Pico CTF. And very similar but from before. Same sort of thing. It's actually the same app, so let's just do it again. Just decompiling the 2 this time. Let it run a bit. Alright, there we go. We can see we get this second folder here. And if we go back into VS Code, there we go. If we go back into Smiley, we can see that the same file still exists. Alright, so let's see what this one has for us today. Alright, so same thing as before, just defining the parameters. We've got a constant here, we've got a new array. Alright, so it's doing some fancy stuff with arrays. We've got a hard-coded string here, and we've got a put object, and then it just keeps going and going. We've got some subtraction, addition. Alright, and then we've got a little further down, we seem to be invoking the string concatenate. Alright, so this is probably the first part of actual reverse engineering here, because what this is doing is basically just being annoying as hell, and just going in and switching things around, so it's really hard to actually read, but the computer does it in like less than a second. So in order to get the flag, we will need to actually go through and figure out what it's doing. So we can probably ignore, where is it? Yeah, all of this stuff. It basically just sets v1 to 0, it sets v2 to the actual string, and then it puts v0 is initialized to the array up here. And then it basically just puts this string at index 0, this string at index 1, so on and so forth. And it does this for all 6 strings. Yeah, 6 strings, because indexes start at 0. Cool. And then in here, we go... Alright. So... Cool. Let's go over here. Oh yeah, by the way, if you're looking at this and following along and everything seems to be just white, that is because Smiley is not a normal language, or not a common language at least. So you're going to have to install some sort of text highlighting if you want it to look pretty and easy to read. I definitely recommend... Where is my extensions? I definitely recommend the second option here, instead of, like, this is the one that majority of people are going to do because, I mean, it has 16,000. This is just a hell of a lot better, in my opinion, because it actually allows you to go back, right-click, and go to definition, which is very useful, especially in reverse engineering. The other one is basically just a text highlighter. So, let's get to actually reverse engineering this. So we can see here that this is setting v1, the variable v1 to 0x3. This is going to be doing what, subint. If we go back to our opcodes and we find subint, very simply just puts the second minus the third, and then puts that into the first. So if we go back to here, oh, not that one, we go back to here, that's v1, which is 0x3, minus v1, which is 0x3. So 3 minus 3, that is v2, is equal to 0x0. Just, these look similar, so I'm going to assume they work the same way. you've got v1 over v1. Well, anything divided by itself is 0x1. You've got the add. You've got the add int. So this actually puts this actually adds the value of v2 onto v3 directly. It doesn't do this 2 registers into 1 register thing, or 2 variables into 1 variable rather. So this does that, and what's this? Well, we've got v3 plus, so 0x1 plus 0x2, that's 0x1, and how many more lines do we have to go? 1, 2, 3, 4, 5, 6. Oh wow, that's actually not as much as I was thinking. Alright, let's see. Let's just smash these out. So 3 plus 3, 3, 1 plus 1 is v4 equals 0x. Alright, 1 plus 1. V4 goes into 0x. What's v2? V2 is 0, so it's just that again. V5 is v1, which the most recent one we've got is v1 here. So 3 plus v4, which is that, so 0x5. We've got v6, which is v5, which is 5 plus v2, which is 0, so 0x5. We've got subint. I really should have done these before the stream. I am sorry about this. V6 plus v3, so that's 0x6. Cool. And then we've got this thing, a get object. So go back to the opcos, a get object, finds the reference of the value, blah 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 blah. Basically, vx, vx here, is that big enough? Alright. Vx here is this destination, Vy is the array pointer, and then Vz is the index. So, whoops, we're looking at getting V7 is array referenced by 5, 5 is 0x5, and all that fun stuff. Yeah. Basically, this goes through, concatenates, moves the result, concatenates, so on, so on, so on. I've only done this part, and honestly, I'm already bored. So let's scoot around what this reverse engineering challenge actually wants us to do, which is reverse engineering. And let's do something they're not really expecting. So if we actually look a little further down the code, after all this concatenation and after all this messing about, we see that we have these lines which gets the password and it checks it, and if it's not equal, if it is equal, then it gets sesame, and that gives us the flag, and if not, it basically just returns nope, which is what's happening here. Something that is really interesting is you can actually just read this as a string, or as normal code, where this, if you were to say do it in Python, would just be return nope. So V8 here is being has nope put into it, and then we've got returning V8 down here, right? What if we changed it to I don't know, v7. Well, what's v7? v7 is up here where the password, the valid password, is actually being put in. So if we were to somehow remake this APK, but with this one character change, theoretically, we would be returning the password we need instead of nope. So let's cheese it. Save that. And if we go do a little bit of digging around, we find that APK tool can actually recompile, not only decompile. So that's just with the B parameter. And we give it the directory, not the APK. And it does its thing. And I forgot to add the output file. So for whatever reason, you actually need to output the -o. You need to add the -o parameter with what file you want to output, because it decides otherwise it's going to build it and then just dump it and do nothing. So there's that. So if we do 21.apk, we get this. And if we have a look, we actually have a second APK. Upload the APK, and we get an error. What's going on here? If we look into it, oh, this is annoying. I don't actually remember how to get to it. Basically, what's happened is that Android is smart and realizes, hey, this isn't actually signed. This is just someone's recompiled an APK. How do I know this is legitimate? Well, the thing is, this isn't legitimate, but we can make it look legitimate. So what we need to do is we need to do some sick Googling, and we get to the holy grail of any computer science major: Stack Overflow. Basically, you can just do this. You don't need to worry about changing alias names or anything. So, copy that. Put that in. Well, that's not entirely true. You do... Oh no, this is just to generate the key. So, enter that one. You enter a password. Re-enter the password, and then just kind of spam through all this stuff. You don't need to enter it. It's just what it expects you to enter. Once you get to this one, it's the whole thing of the owl asks you, do you want to rehear? Do you want to listen to this tutorial again? So don't press enter on this one. I got stuck in a loop about 5 times doing that. Just press yes. And then yes again. Now you've got a key store. So this is going to be on your machine, just generating some public and private keys. It's meant to be used for things like encryption to be put, rather not encryption, verification with the Google Play Store, so you can actually sign it digitally, and nobody really can nobody can emulate yourself, because they don't have this massive key. Yeah. So if we do this, then we use the tool jar signer using the, I didn't change it, so I'm going to assume it's the same key store. And then all we need to do is redo what the APK is doing, sign it again, enter the password phrase you entered earlier, and it's done. And we've got a self-signed certificate on the APK. So let's try and upload that. I've been informed that the webcam is in the way of some of the text. Could I ask what specifically? This was basically just all output. If you want to know anything in particular, those are the commands again. Seriously, just copy and paste. Cool. So yeah, for those who didn't catch it, these were just basically 2 copied and pasted commands. And in the second one, the only thing that I changed was where it says myapplication.apk. I changed that to the APK that I wanted it to sign, which was, in this case, 2.1.apk. Cool. So now I have a self-signed APK, which is dangerous, but it's still allowed. Alright, so let's drag and drop this in. And we see that it's still broken. The reason for that, again, if you go digging through the debugger, thank you for Angus to actually point this out. The reason for this is because we have signed an APK. But we've signed the same APK as picoctf. But we're not picoctf. So since this already has a picoctf application in here, this will be, when we drag and drop this one in, this will be looking to this one and being, okay, who signed you? Who signed this one? Wait, these don't match. I'm going to trust the one that was already on the system and kick this new imposter out. Simple fix for that. Kick him out before he can kick us out. There we go. Drag and drop. Come on. And voila! Without anyone to say that we're not who we say we are, we can get in. And now, if we were to say just password, we can see that we get this different string. We're not getting nope anymore. And if we go back to the code over here, let's make that a little less, we can see that this is actually what the result, this is actually the result of a bunch of these getting concatenated. Almost like that's what the function was doing down below. So, then, if we can just dismass.ogg.methoax. Seriously, who thought of these words? Garlic. Nope, that's being blocked. So, then if we input this string, which should be the password, we get the flag. Now, I would like to say this is not at all what you're meant to do. This is a way of cheesing it, but I mean, hey, it's a CTF. Who's gonna stop you? If you can find a way to do less work, that's pretty much what a hacker is meant to do anyway. Was that English? I think that was English. Wonderful. So that brings us to pretty much all I wanted to show you guys for mobile exploitation just yet. There are 2 more challenges, which include things like signing and re-signing the keys. Signing the APKs. That's what I meant to say. But I won't spoil those for you just yet. I'll let you guys complete Droid 3 and Droid 4 on your own. If you do want any help completing them, or if you have any questions, we are pretty much constantly on Discord. So just shoot us a question there, and one of us will answer probably within an hour or so. Unless it's at 3 a.m. Don't expect a response at 3 a.m. And yeah, I think that's where I'll leave the advanced workshop off here for now. As always, remember that we do still need attendance. We do still need these metrics for MSA, for sponsorships, for a bunch of other stuff. So if you can go to... can I actually bring this up? There we go. Remember to go to go.monsec.io/ attendance. I want to say that's how you spell attendance. Not entirely sure. As well as that, it would be appreciated if you go to survey as well, just so we can get some feedback. If you enjoyed anything, if you didn't enjoy it, let us know. We're always looking to improve. Mariash is putting these in the chat for me as well. And as always, if you aren't already a member of MonSec, go to go.monsec.io/join. I think it's go at least. Let's test that. Live on stream, boys. Professionals. Yep. So go to go.monsec.io/join, and please sign up. We do need the funding. And with that, I hope you guys enjoyed, and have a good night.